video, I'm going to talk about the slots feature in Python. By the end of this video, you'll understand what slots is, why you might want to use it, and how to implement it in your classes. So let's get started. First, let's briefly discuss how Python normally handles attributes in classes. When you create a class and an instance of that class, Python uses a dictionary called _dict_ to store instance attributes. This allows for great flexibility, but comes with a memory overhead. Let me show you this example. I've created a class with two attributes called name and age, and below we have an object being John, aged 20. As you can see, the dict attribute stores the instance variables name and age. While this is very flexible, it can be pretty inefficient in terms of memory, especially when you have many instances of a class. So this is where slots come in. _slots_ is a class variable, and it's a way to tell Python not to store instance attributes in a dictionary. Instead, it uses a more memory-efficient structure. So let's look at the same kind of class, but this time we're going to apply the slots feature. By defining slots, we've specified that our class can only have name and age as attributes. This prevents the creation of the dict dictionary and can save us some memory. I will create another John object so that we can access its attributes with slots. There it is. However, you can probably see a little difference, and the difference is that when we call slots on our object, we can only see the names of the attributes and not the actual values of John and 20. To access these values, you simply use the dot notation as usual. For instance, you would do the following. As you can see, accessing the values of name and age is pretty straightforward, just like with any other class attributes. As mentioned before, the goal here is to use less memory. To demonstrate that, we'll use the pimpler module to check the size of our new objects. First, we need to pip install the pimpler module. I've already done that. And once again, I've created two similar classes, the first one with the default attribute handling without slots, and the other one with slots. The instances below should also have the same kind of attributes. The method of pimpler module that we're going to use is called a sizeof, and it measures the total memory footprint of an object, including the memory usage of its referenced objects and the full object tree. So I'm going to run this code, and we can see that the instance with slots uses much less memory compared to the one without. This can make a significant difference when you're working with many instances. However, using slots has some limitations. Let's discuss a few of them. The first one, we have fixed attributes. Once you've declared the slots variable, you can only use the attributes specified in it. Adding new attributes dynamically is not allowed anymore. What I mean by that can be illustrated by this example. In the default way, we can simply instantiate an object and access the dictionary, and then we can also easily add new attributes. So here is the dict before. Then we can use the dot notation to add an address field, and the dictionary will be automatically updated. On the other hand, here's the class with specified slots. When we try to create a new attribute, it's going to raise an attribute error. That means that we are stuck with the attributes declared in the beginning. Limitation number 2 is no dict. Since we've decided to use slots, Python will not create the dict dictionary at all, so we lose the ability to do the dictionary lookup. As expected, attempting to do so will also raise an error. And last but not least, we have to bear in mind inheritance issues. In the case of subclassing, if a parent class uses slots, the child class must also define the slots variable. Let's look at these in a bit more detail with examples. Here we have a parent class with one slot called name and a child class with the slot called age. When using slots in inheritance, you need to be careful because if you want the child class to have its own slots in addition to the parents, you need to define them explicitly. So this is how we make sure that the child object can have both name and age. And as you can probably tell by now, trying to add any other attribute to the child will also result in an attribute error. To summarize, using slots can save memory by preventing the creation of instance dictionaries, but it comes with some trade-offs in terms of flexibility. You should use slots when you have many instances of a class and a fixed set of attributes. And that's it for today's video on slots in Python. I hope you found it helpful, and thanks for watching.